Yay!
Yay! All right, one more kind of a fun example is we can deal with claims of fantastic events. One claim in astrology, I actually don't know if the claim is still made or not, but one of the ideas behind astrology was that the gravitational influence of the planets are important when you were born. I'm not clear on exactly how they're important or what effect they have, but just asserting that they're important means that we can actually calculate it. We can see if they really are important or not. So, for example, the closest, one of the closest planets to us is Mars. What is the influence of Mars on a newborn baby? Right, the gravitational influence. We can calculate it, and let's compare it to something that might actually happen. Like, let's compare the gravitational influence of Mars on a newborn baby compared with the doctor that's helping with the birth. Now, for sure, Mars is way more massive than the doctor, right? But the doctor is far closer. So let's see, let's calculate it. We can compute. In fact, what we're going to do, because this is going to illustrate another kind of powerful way to reason this out, what we're going to do is form a ratio. We could just compute the numbers. We could compute the forces and just compare the forces, right? But kind of a useful way to do it is to just compare. We'll create the ratio of the gravitational force of Mars compared with, the gravitational force due to the doctor. And both of these are on the baby. All right, well, we can write those down. So what is the gravitational force of Mars? Well, it's G times the mass of Mars times the mass of the baby divided by the distance to Mars squared, right? And then the force from the doctor is just going to be G times mass of the doctor times the mass of the baby divided by the distance between the doctor and the baby squared. Okay, so really the mass of the baby doesn't matter. G doesn't matter. This is why this is one reason that this is sort of an easier way to go, is because we don't have to worry about a lot of these things. If we form ratios, sometimes it just saves calculator work because a lot of factors are going to cancel out. So forming this ratio, let's see, that R, the distance from the doctor squared, that's going to pop up into the numerator. So this just becomes the mass of Mars times the doctor's distance squared divided by mass of the doctor times the radius of Mars squared. There we go. That's how the fractions work. Let's see. The mass of Mars. What is the mass of Mars? I think Mars is like, is it a tenth? Let's see. I wrote it down up here somewhere. Yeah, it's about a tenth the mass of Earth, just about exactly. So the mass of Mars is like 6.4 times 10 to the 23rd kilograms. Now, how far away is the doctor from the baby? Let's just keep the numbers simple. That'll make it easy. Let's just say it's 1. Doctor is 1 meter. 1 meter away from the baby. The mass of the doctor, let's say the doctor is a reasonable 100 kilograms. And the distance of Mars. Okay, now let's do it. Let's be the most generous, right? Let's do Mars at its closest approach. Its closest approach, it's half the distance. Well, if the Earth's distance from the sun is called 1, then at closest approach, Mars's distance from us, or Mars's distance from the sun is 1.5. So Mars' distance from us is a half of the Earth-Sun distance. And so that's going to be 0.75 times 10 to the 11th meters squared. All right, so that's the distance to Mars. All right, so now you can multiply those numbers out. And when you do, let's just see roughly, how's this going to go? Down at the bottom, I've got 0.75 times 10 to the 11th squared. All right, 10 to the 11th squared, that's going to be like 10 to the 22. And then times 100, that's 10 to the 24. And then I'm going to have a 10 to the 23 up top, right? So these two, the numerator and denominator, are going to be pretty close. And in fact, if you multiply all this stuff out, what you find out is that this ratio is about 1.1. About 1. If the ratio is about 1, that means that the influence is about the same. It's about the same force. That's really interesting. So this is about the same force. So the doctor, being 1 meter away from the baby, has about the same gravitational influence on the baby as Mars does. Now, what if the doctor scoots up 0.5 meter from the baby, which certainly probably will happen? Then the doctor's influence is 4 times greater, right? Because we're halving the distance, and it goes as the distance squared. So clearly, I think, in any reasonable sort of birth scenario, the influence of Mars's gravitational force on the baby is negligible compared to even the doctor in the room, not to mention any other family members in the room at the same time, or the mother herself, right? So this claim is, let's just say, dubious.